Now, in order to make sense of that question, we have to provide a little bit of symbol. Okay. Now, we're going to look at a very small cell. There are only two mobile stations, okay, two iPhones, 1 and 2, and one base station. Even though there's one physical receiver, we're going to divide it into two logical receivers, okay, receiver 1 and receiver 2. And we will look at 4 different channels. 2 of them are the so-called direct channels. These are the desired, intended communication path. Of course, in the air, there's no real physical pipe of a channel. So by channel, we really mean a logical link. Okay. What actually happens is just energy propagating in the electromagnetic field and being picked up by antenna. We don't have pipes, as if we're drawing pipes, but we actually don't. So these are logical channels. And we say that there is a transceiver pair from the transmitter 1 to the logical receiver 1, and then from transmitter to logical receiver 2. So happens these 2 logical receivers are physically co-located at the same spot. And then what about interference? When transmitter 1 talks, the energy propagates. Okay? And part of the energy will be picked up by this logical receiver 2. This is a dotted line to represent an interference channel. And there's the other interference channel. And we will use the following symbol, G sub I J, to denote the channel loss on the corresponding direct or interference channel. Now somehow the community got stuck with the term channel gain, even though these G's are numbers between 0 and 1. So it should be called channel loss. Let's say they're called channel gains. Now this is a little tricky. So we'll go a little slow here. It says Gij represents the channel gain from the transmitter of the logical transceiver pair J to the receiver of logical transceiver pair I. So we're going to use the terms user, transmitter receiver pair, or logical transceiver pair interchangeably. For example, G11 is the channel from the transmitter of logical pair 1 to the receiver of logical pair 1. You say, well, that's a good channel. Indeed, it is the direct channel for desired communication. And so is G22. So in general, Gii are the direct channels. But when J is not equal to I, for example, G21, that says this is from the transmitter of pair 1 over here to the receiver of pair 2. And therefore, this is the channel gain of an interference channel. G12 says this is from the transmitter of pair 2 to the receiver of pair 1. And in general, G12 is not equal to G21 necessarily. Now, ideally, of course, we want GIIs to be bigger than GIJs, where J is not equal to I. And indeed, with the help of those spreading codes, those ones and minus ones, we do have usually a GII that's bigger than GIJs. However, there could be many J's not equal to I. Okay, there could be tens of them. And even though each one provides just a little bit of interference to your transmission, they could add up. Okay, that is the cocktail party issue again.